Okay, good morning, children. In the last class, we had discussed about the reactions of haloalkanes, right? Reactions of haloalkanes. And there are three types of chemical reactions there. Nucleophilic substitution reaction, elimination reaction, and the third one is reaction with metals. Then we have learned about this nucleophilic substitution reactions, right? So which are the two mechanisms of this nucleophilic substitution reaction, Michael? Mike, yeah.
Molecular.
No, your voice is not clearly audible. Once again, Michael.
Substitution nucleophilic bimolecular.
Okay. Then another mechanism. Two mechanisms are there, right? One is substitution nucleophilic bimolecular. That is SN2 mechanism. Then one more. Gauri, can you tell me the another one?
Substitution nucleophilic unimolecular.
Yeah, substitution nucleophilic unimolecular. That is SN1 mechanism. Okay. Then what about the kinetics of this substitution nucleophilic bimolecular reaction with her? What about its order?
Follow second order kinetics.
Yeah, why it is known as second order kinetics? Why it follows second order kinetics?
Because the rate depends on the concentration of both the reactants.
Very good. Its rate depends upon the concentration of both the reactants. Then what about the reaction procedure? Is it take place in a single step or not? Emmanuel? Is the reaction proceeds in a single step or more steps there?
More step,
Huh?
single step.
Yeah, single step. Then what about the intermediate? Any intermediate there?
No.
Then what was there instead of intermediate?
Okay,
Which one?
I don't know.
There is one transition state. Okay, there is one transition state. Let's say unstable state. It will remains for a very short time. Then it converted to product. Then what about the other features of this SN2 reaction? Adul? Other features of SN2 reaction.
Inversion of configuration happens during
Yeah.
interaction.
Yes, configuration is inverted. Then what about the reactivity? Which one is greater? Yeah, primary halides, they are always greater than secondary and tertiary in the case of SN2 reaction. Okay, substitution nucleophilic bimolecular. Okay, children. Then these are the main points about substitution nucleophilic bimolecular. It follows second order kinetics. The rate depends upon the concentration of both the reactants. Then the incoming nucleophile interacts with alkyl halide, causing the carbon halide bond to break while forming a new carbon OH bond. That means both the reactions, the breaking of bond and the formation of bond, both take place in single step. Then this is the example for the substitution nucleophilic bimolecular reaction. Then here the inversion of configuration happens during the reaction and the order of the reactivity is followed. Primary halide is greater than, secondary halide is greater than tertiary halide. Okay, these are the points that we already discussed in the last class. Then here about this inversion of configuration, you look at this example. Okay, you look at this example. Here you can see the three hydrogen atoms, they are in the left side, right? They are in the left side. Okay. And when this incoming nucleophile, they attacks this substrate, what happens? This hydrogen atoms, they start moving. Okay. This hydrogen atoms, they start moving away from this incoming nucleophile. Already they are in the left side. Then when this incoming nucleophile, they starts to attack the substrate, this hydrogen atom starts moving away from this incoming nucleophile. And in the second step, you can see both these hydrogen atoms are in the same plane, right? In the second step, both the, not both three hydrogen atoms, they are in the same plane. Okay. And in the final product, all these hydrogen atoms, they are in opposite position to the incoming nucleophile. And you look at the configuration of both this reactant and product. Here the position of hydrogen atom, it is inverted, right? In the reactant side, these three hydrogen atoms, they are in the left side, and in the product side, these three hydrogen atoms, they are in the right side. That's the meaning of this point. Inversion of configurations happens during the reaction. Then we will learn about more things about this configuration in the stereochemistry part. Okay. This is clear, children? About the inversion of configuration. And this movement of this hydrogen atom, that paves the way for this attacking nucleophile to attack on this carbon atom. Otherwise, it will be very difficult for this incoming nucleophile to attack this position. Okay. So in order to make it more easy, this hydrogen atoms, they will move away from the nucleophile. And finally, the position of this hydrogen atoms, it will be opposite to that of incoming nucleophile. Okay, clear? This is clear, children? Yes or not?
Yes, ma'am.
Naurin, Mehak, Shivani, Nia, Nandana, Evelyn, Anthony, Punya, Malavika, all of you switch on your videos. Okay, then the second point, the order of reactivity is followed as primary halide, secondary halide, then tertiary halide. Here, the presence of, you can add this point, presence of bulky substituent, bulky substituents on or near carbon atom have inhibiting effect. Inhibiting effect. That means it will inhibit the incoming nucleophile to attack the carbon atom. Okay. If there will be large bulky groups there, it is very difficult for the incoming nucleophile to attack the carbon atom. That's the reason why which the order of reactivity in this order. Okay, primary halide, then secondary halide, tertiary halide. This is clear, children? Then one more thing to share. This is the transition state here. Okay, this is the transition state. I told you the state is very unstable. While looking through this structure, can you tell me what's the reason for its instability? Can you tell me? This is the transition state. Anyone? The state is very unstable. That means it will be easily converted to product. It will exist for a very short time. What's the reason? Anyone? Any idea? Okay, what about the valency of carbon, children? Valency of carbon. Valency of carbon.
4.
Yeah, it's 4, right? Here there is one carbon atom. You look at the substituents attached to this carbon atom. How many substituents are there?
5.
5, right? So it's already in unstable state. So to attain stability, it will be easily converted to product. Okay, so this transition state, it's an unstable state. It will exist for a very short time. Then it will be easily converted to product. Okay, clear? Yes. Then we are moving to substitution nucleophilic unimolecular reaction. Shall I move to next slide, children? Okay. And the next one is substitution nucleophilic unimolecular. It is otherwise known as SN1 reaction. You can write SN1. This one is wrong. SN1 reaction. The SN1 reactions, they are generally carried out in polar protic solvents. What is this polar protic solvents? Polar protic solvents. Examples are water, then alcohol, etc. What's the speciality of these solvents? Polar protic solvents. They are in polar nature. Again, they can able to donate H plus ions. That's why they are known as protic solvents. Okay. Protic means they can able to donate H plus ions or protons. That's the reason. SN1 reactions, they are generally carried out in polar protic solvents. Examples for such polar protic solvents, water, alcohol, acetic acid, etc. They can able to donate H plus ions. Okay, then the second point, it follows first order kinetics. It follows first order kinetics. That's why it is SN1. Okay. The rate of reaction, it depends upon the concentration of only one reactant. In the case of SN2 reactions, we have learned that it will depend upon the concentration of both the reactants, right? Here, it follows first order kinetics. That means the rate of reactions depends upon the concentration of only one reactant. Okay, so it will take place in two steps. This SN1 reaction, it will take place in two steps. The step 1, the polarized ZBr bond undergoes slow cleavage to produce a carbocation and a bromide ion. This is the step 1. Polarized. Polarized means in the presence of that protic solvent, it's always polarized. And there will be one bond between halogen. There will be one bond between this halogen and carbon. That is CBr bond. Okay. CBr bond. It will undergo slow cleavage to produce a carbocation. I will show the example for this step 1. Okay. In the step 1, the polarized CBr bond, in the presence of this polar protic solvents, they are always polarized. And in the case of this haloalkane, there will be one bond between carbon and bromine. Okay, so this CBr bond undergoes slow cleavage. What's the meaning of cleavage? Here the bond breaks between carbon and bromine and produce a carbocation. Here it is cation. So which charge will be there? Positive or negative? Diya?
Negative.
Carbocation. Yeah, it's positive. Okay. So one positively charged ion is formed, that is carbocation, and another one is bromide ion. It's always negative. Okay. All of you, please switch on your videos. Anthony, Aryan, Krishna, Ashwin, Malavika, Evelyn. So this is the step 1. The polarized CBr bond undergoes slow cleavage to produce a carbocation and a bromide ion. This is the first step. And in the second step, this carbocation, this formed, is then attacked by nucleophile. So this is the second step. So what about this SN2 reaction, children? SN2 reaction, Anna, can you tell me what's the difference between this SN1 from SN2 about the order of reaction? It follows which order? No? Yes. First order or second order reaction? SN2. SN2. First order reaction or second order reaction?
First
Yes.
order.
SN1 is first order. Okay. SN1 reaction is first order reaction. It's in the name itself, right? SN1. That means first order reaction. And in the case of SN2, it is second order reaction. In the case of first order reaction, the rate of reaction, it depends upon the concentration of both the reactants. Sorry, SN2. Okay, in the case of SN2, it depends upon the concentration of both the reactants. Clear? And in the case of SN1, it will depend upon the concentration of only one reactant. And in SN2, it takes place in single step. Both the bond formation and bond breaking, it takes place in single step. In SN1 reaction, it will take place in 2 steps. Clear? This is clear, children? Okay, then you can tell me now, among this SN1 and SN2, which one follows second order kinetics? Now, Rin,
SN2.
SN2, what's the reason?
The rate depends upon the concentration of both the reactants.
Very good. The rate depends upon the concentration of both the reactants. Then Punya, what about SN1 reaction? SN1. Which?
First order kinetics.
Yeah, first order kinetics. What's the reason? I can't hear you, Punya. Once again.
It's placed in single step.
Yeah, it takes place in single step. SN1. Does it take place in single step? SN1. Take place in 2 steps. The reason is that it will depend upon the concentration of only one reactant. Okay. Do not get confused. I will repeat this again. SN1, in the case of SN1 reaction, the substitution nucleophilic unimolecular. It will follow first order kinetics. It will depend upon the concentration of only one reactant. That's the reason why which it follows first order kinetics. Okay, and it take place in 2 steps. It take place in 2 steps. Then in the case of SN2 reaction, that is substitution nucleophilic bimolecular. Okay, it follows second order kinetics. The reason is that it will depend upon the concentration of both the reactants. And it take place in single step. Both bond formation and bond breaking both take place simultaneously. This is clear now? Okay. Do you have any doubt, children? Do you want to repeat it again? Clear, right? Tell me yes or no?
Yes, ma'am.
Yes, okay. Shivani, Ashwin, Krishna, Anthony, Alvin, Lydia, Srihari, please switch on your videos.
Ma'am,
Yeah.
can
Yeah,
you
sure.
slide again?
Yeah, sure. So now we are discussing about SN1 reaction. SN1 reactions, they are generally carried out in polar protic solvents. Examples for such polar protic solvents, water, alcohol, acetic acid, etc. They can able to donate H plus ions. Or H plus ions are present there. That's why they are known as protic solvents. Okay. Then it follows first order kinetics. The rate of reaction depends upon the concentration of only one reactant. Okay, and it takes place in 2 steps. The first step, the polarized ZBr bond undergoes slow cleavage to produce a carbocation and a bromide ion. Okay, so when you write this example, CH3, CH2, Br, this is an example for a haloalkane, right? Haloalkane. So in the step 1, what happens to this? This bond will be breaks. Okay, this bond will be breaks and it will become CH3, CH2, here it is, yeah, carbocation, plus charge, then plus Br minus. It will be formed. This is the first step. I will give you the exact example in the next slide. Now, just to understand, you have to look at this example. Okay, the bond cleavage occurs between carbon and bromine, and it will be converted to a carbocation and a bromide ion. Okay, carbocation and a bromide ion. And in the second step, this carbocation, it reacts with the incoming nucleophile to get the product. Okay, children? Is this clear now?
Yes.
Okay. Nandana, can you please read the slide? The main points about SN1 reaction.
SN1 reactions are generally carried out in polar protic solvents.
Okay.
It follows the first order kinetics. The rate of reaction depends upon the concentration of only one reactant.
Yes.
Step 1. The polarized carbon bromide bond undergoes slow cleavage to produce a carbocation and a bromide ion.
Yes.
Step 2. The carbocation thus formed is then attacked by nucleophile.
Okay. Attacked by nucleophile. And in the case of SN2 reaction, both this bond breaking and bond formation, it takes place in single step. Okay, that's the difference between SN1 and SN2 reactions. Achud, have you completed the slide?
Yes, ma'am.
Okay. Shall I move to next one, children? Okay. So first you can write this chemical reaction. This is the step 1 and this is the step 2. CH3 thrice CBr. It's another example for haloalkane. CH3 thrice ZBr. That means it can be represented like this. 3 CH3 groups around carbon. CH3. Can you tell me this belongs to which type of haloalkane? Primary, secondary or tertiary? Nandana? Primary, secondary or tertiary? This one. Nandana,
Primary, ma'am.
is it primary? Look here. 3 CH3 groups are there.
Tertiary.
Yeah, it's tertiary. Then I will write one example for secondary also. Okay, this one is secondary. 2 CH3 groups. In the case of primary, there will be 1 CH3 group. Okay, that's the difference between primary, secondary, and tertiary. So here, this example, that's tertiary haloalkane. It reacts. Reacts means first in the first step, the polar protic solvents are there. In the presence of polar protic solvent, they will dissociate into a carbocation and a bromide ion. Why it is known as carbocation? Cation means positively charged ion. Here you can see one positive charge in carbon, right? That's why it is known as carbocation. And another bromide ion there. So one carbocation and bromide ion. And in the second step, this carbocation, it reacts with the incoming nucleophile. This one is the incoming nucleophile, OH minus. These two reacts together to form the product. Here alcohol is obtained. This one also tertiary alcohol. Okay, tertiary alcohol. CH3 CH3 groups are there, right? So it is tertiary alcohol. So in the first step, CBr bond breaks and a carbocation and a bromide ion is formed. Then this carbocation reacts with the incoming nucleophile to form the product. These are the 2 steps in SN1 reaction. Clear, children? Have you completed this example?
Yes, ma'am.
All of you?
Ma'am,
Okay.
so what the paragraph on the top?
Yeah, then we can discuss the remaining. So these are the 2 steps. So here, step 1 and step 2 are there, right? So rate of reaction, it will depends upon the slowest step. Okay, there are 2 steps here, and this rate of reaction in the chapter chemical kinetics, we have learned that the slowest step is considered as the rate determining step. Do you remember, children? Slowest step, it is considered as the rate determining step. So here, the step 1, it is the slowest step. Step 1 is the slowest step. So the rate of reaction depends on the step 1. And the rate of reaction depends only on the concentration of alkyl halide. Concentration of this alkyl halide. That's why it follows first order kinetics. In the beginning itself, we learned that the rate of reaction, it will depends upon only the concentration of one reactant, right? So here, step 1 is the slowest step. It is the rate determining step. And the concentration of this alkyl halide is considered as the rate determining step in this reaction. Okay, and note on the concentration of hydroxide ion, because this hydroxide ion, that's in the second step, right? Or in the step 2. We are only considering the step 1 because it is the slowest step. That is the rate determining step. So the rate of reactions depends only on the concentration of alkyl halide. Alkyl halide. So you can compare each point with SN2 reaction. Okay. This portion is very important about SN1 and SN2 reaction. It is very easy to learn. You just need to compare each point with 2 mechanisms. Have we completed the first point? Rate of reaction, it depends upon the slowest step. That is the step 1. The rate of reaction depends only on the concentration of alkyl halide and not on the concentration of hydroxide ion, because hydroxide ion, that comes in the second step. Second step is not considered as the rate determining step. And what's this double-headed arrow indicates? Vidur, what's the meaning of this double-headed arrow?
Reversible.
Very good. It's reversible in nature. Okay, that means both forward and backward reaction can take place. And the second point, that's about the reactivity order. Okay, reactivity order. In SN2 reactions, we have learned that primary halide is more stable, or the reactivity is more for primary, then secondary, then tertiary. Here, the order is reversed. Tertiary halide has more stability, then secondary halide. Third one is primary halide. Can you tell me what's the reason for that? Can you guess? Anyone? Here, tertiary halide has more stability compared to secondary and primary halide. What's the reason? In SN2 reaction, we learned that bulky substituents present there. It is very difficult for this reaction to take place. Here, tertiary halide is more favored. What's the reason? You have to remember the first step. What's take place in first step? What's the product formed there in first step? Gauri, can you tell me what's the reason for this order? Just guess.
Formation of carbon.
Very good. Formation of carbocation is there, right? In the case of this primary, secondary, and tertiary carbocation, this tertiary carbocation is more stable compared to secondary and primary. Okay. In the first step, you learned that CBr bond breaks and a carbocation and a halide ion is formed, right? So there is one formation of carbocation there. In the case of this carbocation, always tertiary carbocation is more stable compared to secondary and primary. That's why it follows the order. Tertiary halide, it is greater than secondary halide, it is greater than primary halide. Okay, so Do not get confused with the order of reactivity in both mechanism. In SN2 mechanism, it follows primary, secondary, tertiary. And in SN1 mechanism, tertiary, secondary, primary. You have to remember the reasons also. The case of SN2 mechanism, it is due to bulky substituents there. That's why the tertiary halides have less stability or less reactivity. Here it is due to the presence of carbocation. We can add here due to the presence of carbocation. This carbocation, tertiary is more stable compared to secondary and primary. So the reactivity also follows the same order. Tertiary halide is greater than secondary halide. It is greater than primary halide. Okay, this is clear? Any doubt, children? Any doubt? Nothing, right? Shall I move to next point? Then the third point, that's the order of reactivity of halogens. Order of reactivity of halogens. We have learned that there are different halogens present. Aditya, can you tell me the names of halogens?
Fluorine.
Yeah.
Bromine.
Once again?
Fluorine. Chlorine. Bromine.
Okay. Fluorine, chlorine, bromine, iodine. These are the different halogens present in group 17. Okay. Then the order of the reactivity of different halogens, Ri, that is iodoalkane, right? Or alkyl iodide. It is greater than alkyl bromide. It is greater than alkyl chloride. Then it is very much greater than alkyl fluoride. So this alkyl iodide, it has the maximum reactivity. If iodide ion is present there, it has the maximum reactivity. This order of reactivity, it is common in both mechanisms. In both SN1 and SN2, it follows the same order. Ri, it is greater than Rbr. It is greater than Rcl. It is very much greater than Rf. Okay, so this is the order of reactivity of halogens in both mechanisms. In SN1 and SN2, it follows the same order. Clear? This is clear, children?
Yes, ma'am.
Okay. So these are the main things about SN1 mechanism. Then we have already learned about SN2 mechanism. Okay. Do you have any doubt in any question or any portion from the previous part and this one, two mechanisms? Anyone? Nothing, right? Okay. So we can just compare the features of both type of mechanism. First one, this way, children, SN1. SN1. Here it is SN2. Okay. Evelyn, what's the full form of this SN1 mechanism? SN1.
Substitution, nucleophilic, unimolecular.
Very good. Substitution, nucleophilic, unimolecular. Unimolecular. Okay. Then Anna, what about SN2 mechanism? What's the full form?
Substitution.
Substitution,
Nucleophilic.
nucleophilic. Then
2 mole.
yeah, tell me, nucleophilic. Then for 2, what root word we will use for 2? Anna, 2. Here it is uni for one molecule.
Dimol.
Here bimolecular. Okay. Di also used, but here he used the term bimolecular. That's the full form. SN1 substitution nucleophilic unimolecular, SN2 substitution nucleophilic bimolecular. Okay, then Aditya, what about the order of SN1 reaction? SN1. First order or second order?
First order.
Very good. It's first order. First order. Then Vidur, what about SN2 reaction?
Takes place in one step.
First
Takes place in
or
two steps.
second order? SN2 first order or second order?
SN2 second order.
Yeah, second order. Second order. Then Sharon, how many steps are there for SN1 reaction?
Single step,
SN1
double step.
take place in two steps. Okay, take place in two steps. Then Mehak, what about SN2? How many steps are there?
Single step.
Yeah, take place in single step. Single step. Okay. Then here, along with this first order, you can also write rate of reaction depends upon only one reactant. Concentration of one reactant. Okay. Then in the case of SN2, here the rate of reaction depends upon the concentration of two reactants. Concentration of two reactants. Okay. What about the order of reactivity? Which one will be greater in SN1 reaction? Primary, secondary, or tertiary? Achut, can you tell me in SN1 reaction, which one has the most reactivity?
Primary.
Very good. So here the order is, just wait.
Ma'am, in SN1 it is tertiary.
No, SN1 it is primary, right? Yeah, tertiary. Yes, very good. Tertiary. Tertiary, secondary, primary. Because due to the presence of carbocation. Carbocation. Okay. Then what about SN2? Michael, SN2. What about the reactivity order in SN2? Which one will be greater reactivity? Primary, secondary, or tertiary?
Tertiary greater than secondary, greater than
Primary
primary.
greater than secondary, greater than tertiary. Here due to steric effect or bulky substituents. Bulky substituents. Due to the presence of this bulky substituents, it is very difficult for the incoming nucleophile to attack the carbon atom. The same thing is known as steric effect. You can also write steric effect. So these are the main differences between SN1 and SN2 mechanism. Shivani, can you please read each point? SN1 and SN2.
SN1 substitution nucleophilic unimolecular.
Okay.
SN2 substitution nucleophilic biomolecular.
Bimolecular. Then
First order reaction and second order reaction
Hmm.
take place in 2 steps.
in
Take
SN1,
place
then in SN2.
take place in single step.
Okay.
Then rate of reaction depends upon only concentration of one reactant.
Yeah. In SN2.
Rate of reaction depends upon the concentration of 2 reactants.
Yeah. Then what about the order of this primary, secondary, and tertiary in SN1 reaction?
3 2 then 1.
Tertiary. This is tertiary. Okay. Tertiary. Then secondary, primary. Okay. Tertiary, it is greater than secondary. It is greater than primary. Then what about SN2? SN2. What's the order?
Primary.
Yeah. Primary is greater than.
Secondary.
Yeah.
Tertiary.
Then tertiary. And in SN1 mechanism, this order, it is due to the stability of carbocation, and in SN2, it is due to the presence of bulky substituents. In the case of tertiary, there will be lesser reactivity. This is clear, children, about SN1 and SN2 mechanism. Do you have any doubt? Do you want to repeat any points again? Tell me, yes or no?
No, ma'am.
Okay, it's clear, right? So these are the 2 types of mechanism in a substitution nucleophilic reaction. Okay, substitution reactions. There are 2 types mechanism there. Substitution nucleophilic unimolecular, that is SN1 mechanism. Then substitution nucleophilic bimolecular, that is SN2 mechanism. Then the next part that about the stereochemical aspects of this mechanism that we can discuss in the next class. Okay, so all of you read this portion very well. It will be little bit confused about the points, but when you learn it thoroughly, it will be easy for you. Okay, then let me take your attendance. Just wait. Okay, thank you. Bye.